In this problem, I have 4 setups. The setups look very similar, but they have fundamental differences between them. So as we go to the right, the setups become complicated as compared to the previous one. So we have springs, we have pulleys, we have ropes, and we have masses. Okay. The pulleys are frictionless, the ropes are massless. So in the first diagram, what you can see is that both the pulleys are fixed. This pulley is fixed to the bottom, this pulley is fixed to the top. There is a rope running over the pulley. At one end there is an object of mass m. On the other end, the rope is connected to a spring of spring constant K1. Okay. Now you have to find out what would be the natural frequency or omega in this setup. When you are asked to find out what would be the natural frequency of simple harmonic motion of a system, it means that if this object is moved by a small amount, then you have to find out whether this system moves in a simple harmonic motion or this object moves in a simple harmonic motion. If it does, then find out what would be omega. Okay. So I hope the diagram is clear. Both the pulleys are fixed. This pulley is fixed to the bottom or ground. This pulley is fixed to the ceiling. Okay. Through this something over here. The object can slide over the pulley. There is a rope which moves over both the pulleys. The pulleys are frictionless. The object has a mass of m. On the other end, there is a spring of spring constant K1. Find out what would be omega. In the second setup, what is done is this pulley, which was initially fixed to the bottom, the fixing thing has been removed. Instead, a spring of spring constant K2 has been fixed over here. That means this pulley is now movable in this direction, compressing or expanding this spring of spring constant K2. All other things remain same. In this situation, find out what would be omega, what would be the natural frequency of vibration or simple harmonic motion of this system. In the third setup, again, this spring has been replaced by the rope. That is, the entire rope moves up to the top. Instead, this pulley is also made movable. So spring K1 is not there, but both the pulleys are movable. This pulley is still connected to this spring of spring constant K2. This pulley is connected to this spring of spring constant K3. Okay, there is a spring over here, mind it. So this pulley can also move in this direction. Hence, here also find out what would be omega. That is, if this object is displaced by a small amount from its natural position, find out what would be omega. The fourth setup is most complicated, where we have K1, we have K2, and we have K3, and find out omega for this particular situation as well. Okay, so what we would be doing is we would be solving these 3 setups in the follow-up videos. If you understand these 3 setups, you can solve out 4th setup by yourself. I would not be solving 4th setup. 4th setup would be left to you as homework. Okay. Try this out by yourself. If you have any problem or if you want to verify your solutions, please jump into the follow-up videos. We'll be first solving this setup, then go into this setup, and then go into this setup. Remember, the first setup is actually very simple, but still we will be solving them first. So let's jump into the follow-up video for the same. Thank you.